Swadikap. Hello everyone, my name is Vadit Limlawan. I am PhD student and the advisee of Dr. Ponte from Kasetsart University, Thailand. Today I would like to talk about our topic. The topic is development of waiting time predictor based artificial neural network. Okay, this is our outlines of presentation today. Let's start with the queue. Queue is everywhere in daily activities and parts of service. The activities such as banks, public transport, and hospitals. Long waiting has a negative effects on service satisfaction, although the service is not bad. However, service provider cannot eliminate waiting time in queue because it is very costly to do so. The cost and resources its service systems are limited. To reduce dissatisfaction of customers, some business provides queue length information to each customer. The problem is the given queue length is often larger than the actual queues because some customers left before receiving service and the system does not update the number of queues. So customers estimate waiting time from the largest queue lengths and decide to leave from the queues, and the business lost revenue from leaving customer and may lose the customer to competitors. Okay, based on the problems, the provides accurate waiting time for each customer is another way to increase customers' satisfaction. With accurate waiting time, customers can plan their activities while waiting for service. The objective of our research is to propose a queue system that can provide accurate waiting time to each customers. Okay, next we will talk about the waiting time predictors. First of all, we talk about the queue theory based predictors or QT. QT is based on a GMN queue system. QT is easy to implement because the equation is so simple. We use only queue lengths, service rate, and the number of servers at that times. But the QT may not accurate in queue system that has customer abandoned. The system does not update queue length when customer leave. And the next predictor is historical based predictor. We use the last customer to enter service as the historical based predictor or LES. The waiting time is predicted by using the waiting time of the customer who recently entered service, and the disadvantage of this predictor is queue enrollments. The queue enrollment of the last customer who entered service might not be the same as the enrollment of the new customer. And the next is the linear ligations. In waiting time prediction, variants of linear ligations were applied to predict waiting time, and the linear ligation may not accurate if the queue length and number of servers do not have linear relationship with waiting time. In this research, we use the queue length divided by the number of servers as the independent variables of the linear ligation. And the main predictor of our research is artificial neural network or ANN. ANN is powerful tool that can solve multi-dimensional input and output problems. In waiting time predictions, ANN has been applied to predict waiting time in call center and bank. In this research, we use only feed-forward ANN. The feed-forward ANN has only the single hidden layers. In the hidden layer, we use the hyperbolic tangents, sigmoid functions, and we use the linear function as the activated function in the output layers. This is the symbols ANNs that we use in our research. Before talking about the proposed systems, I will talk about the disadvantage of the ticket queue system. The disadvantage of ticket queue is inaccurate queue information. The ticket queue system does not update queue lengths when customer left the system before receiving service. Queue length and estimate waiting time is often larger than the actual queues. So, from the problems, we developed the proposed queue system. The main concept is update queue information. We update queue lengths from waiting area and update number of counter or servers and update service list from the counter areas. And for update queue length, we use video surveillance and computer vision. And for the average service time, we use exponential with moving average control charts. And this is the step of the EWMA control chart. Step 1, initial mean standard deviation, and initial predict service time, and then predict service time, and compare with the lower bound and upper bound. If predict service times more than upper bound or less than upper bound, we update mean of service time. And once we got the information from the system, we send the information to the predictor. In this example, we send to the ANN predictors, queue length, service time, and number of counters, and we will predict waiting time from that information. This is the concept of our proposed system. Okay, to evaluate the performance of predictor with our proposed system, we design the test systems. The system open X hours a day or per applications. The service time is normal distribution with mean 1 and standard deviation of 0.75, and the mean may shift at 11 o'clock. And the load of system is dramatically changed in the applications. And the arrival rate is Poisson distribution with a mean of lambdas, which is adjusted based on the load and the service rate. The lineage time of customer is seconds along distributions with a mean of 15. And the test case, we have three test cases that divided by the shift size of average service time. Case 1, no shift. Step 2, positive shift. And case 3, negative shift. Training data says is run 30 replications and 10 replications for test data sets. All test data sets were simulated by simulation arena Rockwell software. And for the predictor in the experiments, the QT, we did not install the proposed system in the QT because we want the QT to represent the traditional ticket queues, and we want to compare the linear regression and artificial neural network with our system to the QT. Okay, this slide shows the parameter setting in the experiment. ANN, the number of neurons in the hidden layer is equal to 5, and ANN is trained by backpropagation algorithm in MATLAB, and other predictor caused by Excel VBA, and this is the lambda and L of the EWMA control chart. And for the performance measurements, we use mean square error or MSE and the percentage of accuracy within acceptance tolerance. Okay, let's talk about the results of the experiments. QT is the best predictor in case 1, but ANN is still better than other predictor. ANN with the system is better than QT in case 2 and case 3. Linear regression is the worst predictor in all cases. And this slide shows you the plot of the actual waiting time and the predict waiting time by QT and ANN. The predict waiting time by ANN is closer than the actual waiting time than the predict waiting time by QTs. And for the percentage of accuracy, approximately 95% of waiting time by ANN is accurate within 5 minutes for all cases, and almost 100% is accurate within 10 minutes for all cases. This brings me to the end of my presentation. To sum up, we propose the design of queue system that can improve the accuracy of waiting time predictions for each customer. And compared to other predictors, ANN with the proposed system show better results than the others. More than 95% of predictor waiting time by ANN is accurate within 5 minutes. For future work, more cases on service time and customer abandonment will be studied for investigate the effect of them. Thank you for your attention and stay safe.